would like to ask Gregor to again show his camera and join me on the screen. Oh, you have the same background? I thought you were like gonna switch backgrounds all the time. No?
No, next time. Good idea.
Okay. Is that like is it a secret binary message you have there, or
Let's take this offline. I cannot confirm or deny this now.
I think it's a mnemonic, right? In binary code. Oh, anyway,
Yeah,
you're
I cannot comment. But Igor knows. Igor knows.
okay. So anyway, what you probably can comment on is what we will be discussing next. Um, this next section is about the ecosystem, which is basically all the projects and people around Swarm that make this endeavor happen. Now, first thing we should talk about, I think, is well, Fair Data Society. I think this whole section is sort of about Fair Data Society. Um, I would do a call to go to the practical stuff as soon as possible, because I feel like the crowd we have here and the audience we are
Yes.
attracting is totally with us if we talk about ethics and if we talk about principles, etc. So I would love to, show what we have been working on, because
Yes.
this is so exciting. So Gregor, but
Yes.
let's first maybe go through the ethics and why is Fair Data Society so important for Swarm and vice versa.
So, thank you, Michelle. So, I'll try to keep this as brief. Please do interrupt me, because today we had a great workshop where we had the time to speak, and I would invite actually everybody who wants to know more about this topic to check out the workshop and to join next time new workshops. Uh,
Yes.
in essence, it's Swarm is growing, which is what we've been communicating throughout also the previous events. The efforts are growing, and what we also see today is there's a lot of moving parts. The panel we just had is very informative, and it's a world on its own in this regard. We are now, I know, a bit of a spoiler, like also the demos that we are going to see it. It's exciting. So. But at the same time, it's also developers. We want essentially to build good things also, not just things that work. And in order to do this, and in a way that we do it well, we need to do it in a collaborative way. And for this, it's also important we have shared understanding and sort of like also defined shared values. So, also in Swarm's case, Swarm, we're good at code, we're good at developing. At the same time, we also want to see, uh, we speak about fair data economy, fair data to emerge fair data economy, not that mistakes of the previous internets are repeated. And
Are
for
you basically
this,
saying that the developers don't have ethics?
no, 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 not at all. I think what I'm saying is that we need to speak about this. I think what that we need to align, and that we need to basically through such alignment we can do better, and we can maybe avoid some of the mistakes that were done in the past.
Yeah.
So
Do you think
around,
that? Do you
yeah,
think that? Do you think that like a lot of the, you call it mistakes from the past, but I mean you're such a nice guy, right? I would just say like it's a big scam. I mean you're not. I'm not
yeah,
convinced. If I look at the social dilemma, they say like yes, but nobody meant to do harm. And then at the same time, I read that Mark Zuckerberg ordered his people to make Facebook as addictive as cigarettes. So
yeah,
I mean, I just want to point this out because it's so easy for us all to say like um, we are doing things by accident, and if and you might develop a nice thing like a like button, and then if you scale it up, then it becomes a problem, etc. But this is, I mean, I'm not. I don't agree with this. Like in many cases, it's the it's basically the incentives of an old school capitalistic world that lead to these kind of yeah um, I can swear, right? Like fucked up
yes,
situations. And
yes.
so how do you think then that, I mean, it's I'm sorry, I don't want to attack I don't want to attack your um,
No, no. Please
talk
continue.
here, but like how can we make sure is talking about ethics enough? I mean, to me it feels almost like everything you develop, every time you write a line of code, you are stating an opinion, right? Even if you're just a front-end developer and you're choosing a CSS rule, even if it's a color, you're opinionated, right?
Yes, exactly. And we all are human. You know, it's like we also incorporate our own biases, or we don't think about things. So that's why it's, you know, the social dilemma movie is great, but the takeaway, what I miss actually in the social dilemma movie is the talk about principles. I missed that they would say like, let's do like this kind of apps, you know, let's have like this framework to evaluate. Let's think about this. Let's think about what kind of world we want to live in.
Yeah, but
So,
this
and
is a big
yeah,
political question then, right? It's not, it's no longer about, I mean, I think we can, it's sort of easy to map digital ethics to, human rights, and we talk about digital human rights, etc. But living in a capitalistic or neo-capitalism is or a neoliberal system, that's not, it doesn't seem like ethics, right? This is politics. So where do you see the border between ethics and politics?
mhm. I think it's like I basically see ethics a bit like meta in the sense that just by, you know, engaging with ethics, it brings some questions to the forefront. It structures the dialogue. This can be also be applied in politics itself. It could take the politics to the next level. It's in the sense what we are seeing today. It could be also argued from the ethical perspective that this void that we have because of the lack of the shared understanding and values has been filled with this consumer capitalism messaging that goes on more like lower impulses of the emotions and, you know, to provoke our reactions, instant gratification. It's like the misaligned incentives that we speak. But do we know how to design aligned incentives? How do we think about this? You know, and here the principles that we try to basically use, that we start a dialogue and that we coordinate as an ecosystem play a major role because they we are creating together our space, our mind space. It's like we're with the shared understanding, uh, we are in essence united in what we want to see to happen,
Yeah,
what we
yeah,
want
and,
to build.
and still, yeah, I mean,
Yeah,
I totally agree when we talk about design ethics in technology, but I
yeah.
still, I wonder how aligned this entire space is if you start talking about, um, do we, for instance, a question would be, do we agree that there's like unlimited growth? You would say like in capitalism, it's about like unlimited growth and gain as much as possible for yourself. Get a big chunk of the market cap of whatever token we're talking about, right? And so I would argue that this is a fundamental problem. This is what leads to the behavior that these companies are doing. And well, anyhow, it's something I've been thinking about a long time, the last couple of weeks, and especially this movie, The Social Dilemma, made me realize, like, it's not only a question of technology, or it's not only a question of incentives and business models. It's like a way deeper problem that goes back, like maybe probably like thousands of years that we have to think hard about. But anyway, shall we?
Exactly, and you know, and at the same time, we see this translates usually into a simple metric, net screen on time or stuff like that, you know, where it kind of reduces the person, us as the product, to one metric and what kind of behavior wants to be triggered,
Yeah, I
you
think
know.
I think the point I want to make is like we're not only a metric in digital space. I think most people working in companies are being measured in metrics, like how many hours they
Yes.
work, how many sick days they have. So anyway, let's let's continue this.
Maybe let's have the code speak more a bit and
Yes,
we
yes,
invite them.
exactly. So that might be a solution. I think just write code, and if people use it, then you don't have to talk about opinions and politics anymore, because it will be in the tool itself. And I don't know who said it, and it might have been Steve Jobs, but I believe that the world will be shaped, our community can be shaped by the tools it is using. Right. I mean, this
Yes.
is how
Yeah.
we got this far as a Homo
Yeah.
sapiens, by
Yeah.
by the tools we were using. Our society changed, and maybe this is the next step. So let's talk about
Exactly.
tooling
Before and before we conclude this, we need to give a call to action that yeah, we invite everybody to check out the principles, to see the what they're about, and to challenge us, to engage the discussion.
definitely, yeah.
Yes.
Yeah.
Thank you.
So, so if we have housekeeping messages, I'm sorry, I totally ruined it with going into this
Yeah.
activist conversation. We'll come back to that later. So, first of all, I would like to invite Dan to.
Bye bye.
Yes, I'll see you later, Gregor. So, Dan, are you there?
I am here.
Yes.
Thank you,
Do you have,
Michelle.
do you have an opinion on? Do you have an opinion on this conversation we
Yeah,
just
so
had?
about ethics. No, I think it is. It's fundamentally important, and even coming from a developer's perspective, you can see that the dark and light UX patterns that are built into the apps are absolutely fundamental to guiding human behavior. I think it's something that we need to think about as devs and really consider how we're fundamentally changing people's lifestyles and causing them to go down different paths.
I leave it up
The
to you
big
now.
thing-
I'm going to mute myself and give you the stage or the screen.
Okay, thank you. So yes, I'll get onto the slightly more concrete subject of building apps on Swarm. So with the beta release, we're really getting to the point now where we've got a really impressive set of tooling to be able to start building applications on top of the Swarm network. And we're in the middle of quite a fundamental phase shift with the way that this works. Previously, the Swarm client has been kind of monolithic and all-encompassing, but we're now moving over to a slightly different scenario where the client itself is more concerned with the disk and propagating data through the network, the incentives layer, and so on. It still provides a rich API, but we have much lower level access now to the basic Swarm primitives. And this really opens up the possibilities of what we can do in terms of app development. And we're really only just starting to scratch the surface of all the different paradigms that we can build on these basic, wonderful primitives that the Swarm team have dreamt up for us. So I'll share my screen. And really the best entry point by far is just to go straight to the documentation. We're concentrating on the actual functionality of the client at the moment, but there's starting to be so many more possibilities for what to be able to do. So you can go to docs.swarm.org and browse through. We've got a nice new set of hopefully very clear documentation. Do feedback and let us know what your experience of that is and any issues that you find or any improvements that you think we might be able to implement for you. New in beta is PSS messaging. And go and check out the tutorial here. So this is essentially a pub subsystem that sits on top of Swarm using the Trojan chunk primitive, which I'll discuss a little bit more later. So you essentially can subscribe to a WebSockets feed, and then other users can send information across the network that is only able to be decrypted by you. So we've got a zero leak communication pub subsystem. And this is just one of the possible ways to build applications on Swarm. There are basically 3 different chunk type primitives: content address chunks, single owner chunks, and Trojan chunks, all of which that can be used for different purposes. And these low-level primitives are discussed at length in the book of Swarm, which we encourage you to read. There's a section on advanced high-level structures that are built on top of it, the basic disk. This, for example, is a discussion of aggregation, whereby all of the individual users represented by the different colored dots here own their own data and can retain sovereignty over it. But then in order to increase the efficiency and to make this kind of stack up from a scalability point of view, there's this aggregation procedure that takes place. There's other things we can discuss, such as the universal outbox feed. So this is an example of how to put together persistent messaging over the top of Swarm using single owner chunks. You can see here this is one of the more complex implementations that's discussed the idea of sending multiple single owner chunks, which are deterministic based on their topic and index, in such a way that the receiving user can actually preempt their arrival, creating a low latency messaging system, chat, and so on and so forth. You know, like various kind of like forward messaging, forward secrecy rather, backward secrecy, and so on. This is an example of the Trojan chunk itself, whereby a nonce is used to mine a chunk that naturally falls into a node's neighborhood of responsibility. And then all these chunks are processed to determine which are Trojan chunks. And those that are found to be messages are then revealed only to those with the corresponding decryption key. So at the moment, we're just at a point where we've really got to grips with what should the client library be. We've done a lot of proof of concept, so watch this space for developer tooling coming out to enable like JavaScript access to these low-level primitives that you can then push chunks directly into the swarm. And then on top of that, we're also going to be looking at building more high-level libraries. FDS.js was a proof of concept built on the old Swarm client, and you can see this as the GitHub repo under Fair Data Society has high-level constructs that enable accounts to be created. It interacts with the blockchain and enables you to send messages, upload files, plug your own contracts in, so on and so forth. So it's really like we're looking at providing like a jQuery or like Rails level interaction, and this will enable then apps to be produced as simply JavaScript files, and all of the rest of the infrastructure works on Swarm, which, as we've mentioned, completely changes the game in terms of development, because not only do you not have to maintain a large back-end infrastructure, but you also don't need to directly pay for that, because your users will cover the costs themselves incrementally in piecemeal. So yeah, do get in touch with us. We want your use cases at the moment. So we're looking for people to get in touch with us, and for us to be able to support you to build your applications on Swarm. We've got bandwidth at the moment to not only help you find your way through the process, but also to directly support you, and maybe even respond to your specific needs if they're not already catered for. So that's about it from me. Go back to Michelle.
Well, thank you so much, Dan. As always, it's so much, I mean, it's really relaxed listening to you explaining stuff, to be honest. I always go sit back a little bit, and yeah, it's probably your voice and the beard. Anyhow, thank you for that. And as Dan said, like, we are looking for use cases. I think, when are we announcing grants? I think Fair Data Society also is, last time you announced some grants, Dan. I mean, you were playing Sinterklaas, what is it, Santa Claus?
Yes, well, we may have that announcement a little bit later in this segment, I believe.
Oh, okay. I'm so sorry. Thank you for reminding me of the program. Okay, so I think then next up is Zahur. Hello, Zahur, are you there? And this is gonna be the this is one of the things I always look out for, or look forward to. the most because Zahur is going to show us very hands-on what he has been working on for the last couple of months. Are you there? I can't see you, but
Thank you, Michelle. I'm there.
there you are. Awesome. Yes. Okay.
I can see
So
you.
please, Zahur, go ahead, do your thing.
Yeah, it's actually a little late, so I am sort of feeling sleepy. So
Yes, but because maybe you should tell what your time zone is, where you are in the world, because otherwise people will think you are lazy.
uh, yeah, so I live in India. My name is Zahur. I'm involved in some project for the past, I think, 3.5 years, on and off. So yeah, so I'm going to talk about actually a project called Fair OS now. Let me share my screen with you. Where is that? Yes, the browser. Okay, so this project is something which I managed to work when I was working with Swarm full-time. I believe that this is important for the adoption of Swarm, and this comes under the Fair Data Society umbrella. So before going into what is Fair OS or anything like that, I'm going to skip some slides and come actually directly to what this is all means. So if you look at the Fair OS, it is split into two major layers. One of them is called Fair OS DFS, which is decentralized file system, which is what we are going to talk a lot about today. So to give a context, we know about Swarm. Swarm is very good at providing fundamental blocks to build a Web3 storage system. When I mean fundamental blocks, it builds all the protocols necessary to do all these things. It builds stuff to add more tooling on the top, like single owner chunks. It builds fundamental stuff like Trojan chunks, which enable PSS message kind of thing. So it really concentrates a lot on building the fundamental stuffs and making it perfectly right. And now we have a lot of application developers who want to work by storing their data on Swarm. There are different kinds of applications. There are different data access characteristics of each application and all such things. So one of the things that which came to our mind is that why don't we accelerate the development of these third-party apps or these dApps that people try to develop on top? A lot of them are used to Web2 kind of interaction in the UI world, and what if you could actually provide a very similar interface to them, but at the same time make them use of the entire Web3 portfolio, right? That is like giving the cake and having to eat it too, right? So what we tried to build is, a layer called Fair OS DFS. DFS stands for Decentralized File System. So what it does is that it does some major functionalities, like user management, how to create a user, how to store the metadata of the user, how to store the key of the user such that it's available only to the user, but still it's present in a decentralized system. I think the second most important thing is to provide a logical file system on top of Swarm. We did this effort long back, 3 years back, by building a Fuse operating system, like a Fuse driver on top of Swarm to mount the entire Swarm collection into a normal Linux file system. But what we thought is that we need something more. We need something more which is structured, which is controlled by the user, which doesn't have any kernel interactions. Everything is user side and all these things. So this logical drive provides a lot of information like that. And then comes a lot of other things like permission management. When I want to share files with others, when I want to have a group logical drive like NFS drive across an organization where a lot of people have permission to read and few have permission to write into that and all this kinds of stuff. And then I think the very important thing is about file formats. This is something not directly related to a file system, but I think it's important to create something like this because to actually cater to the needs of different access patterns of the data. Some application might need really fast access patterns. Some application might need lot of data in actually a batch fashion. Some application might need to store streaming data and retrieve this data, all these things. So a lot of things. I mean, I don't have actually time to say about this. And then at the end, what we also want to build is some kind of native, Swarm native index data structures so that we could help build people dynamic apps which can change state or which can store the state, which can update the state, which can be very dynamic like we have today, like we have the apps like today, right? So for them to store data in an immutable file system and then to update the data needs some logic that needs to be thinked of by the developer side. So what we thought is that we all encapsulate all these things in a very nice package and expose APIs and REPL commands and data drivers like SQL drivers and other data drivers so that applications can start using this data like normal database or any other data storage systems that they are used to, like NoSQL or whatever. So this is what we built it. And this can be used for applications like dApps, like FairDrive, FairDrop. These are example dApps which can start using these things. Or you can use the existing big data frameworks that is there out there that a lot of open source people use to process large amounts of data and still store the data in Swarm so that the data is very confined to users, it's permissioned, you don't just take out the data of some user without its permission and all this stuff. So this is the major use case. So now I'm going to directly jump to two use cases. One use case talks about the introduction of FairOS DFS because that is the only thing that is that we have started doing. And the second thing is about how to share file between two different users who are connected to two different Swarm nodes and how can they share data and how fast is it. So I'm going to go to the demo here. The first demo, what you see on the top is actually it's actually a B node. I start in my local system, and what you see in the bottom is actually a DFS node. I start in the local system. I point the DFS node to the B node and the stats. So the B node stats, it's a new B node. Its API address is localhost, and FairOS DS is connected to localhost. FairOS DFS, okay, I'm just going to pause here. So you create a new user. User is the basic unit, which is on the top. So every user needs to create one user. Below that, he can create different drives. Drives are like in a Windows system, you create C:, D:, E:, and store different things in different drives. these are logical drives, right, which is on top of the real storage device. So you can create logical devices or logical drives and start to put information inside the logical drives. So when you create a user, if you don't supply any mnemonic, I myself create a mnemonic and expose it so that the user can store it. Otherwise, in later stages, we want to use external signers like Clef or other such signers like Ledger and all these things, so that this is not really exposed to outside world. You can be sure that this is your data. So next, what it does is that it tries to create a pod. A pod is, as I said, is a logical drive. So it creates a pod called my drive, and there is nothing in the pod. So it creates a couple of directories in the pod. It tries to upload file from the local file system into the pod. When I say 10M, it is the way in which you want to split the file and store it into B. And also when I say false, it is the compression argument. So if you have a text file or something like that, you can make it true so that it is really compressed, right? So this is uploaded. If you see on the top, I tried to show what is the size of the file. It's 156 MB. So yeah, the file is uploaded here. Once the file is uploaded, you can see the file during ls, and you can also do something called a stat. Stat shows a lot of details about the file, about which pod it is there, and what directory, what is the file size, what is the block size in the file. And it shows for every block. Blocks are numbered with block 00000 to 00009 or 99999. So every block, it shows what is the swarm hash. So as you can see, the swarm hash here is long, which means it's encrypted block, and it shows the bytes of the block. And if it's compressed, it will show the compressed size of the block. So this is like a cool thing. So if you want to give this file to process in a parallel fashion, all these blocks can be processed in a very parallel fashion using any computation framework. So what I do here is that I again log out, I log in into the same user drive, and I see the same file is already there, right? So this is the basic demo of Pharaoh's DFS. Now inside the second demo, you see four terminals. The top two terminals are two B's local instances. I tried to connect them to form a small network. The B on the left is, the browns, not the brown, the black window on the left is the DFS that is connected to B1. The black window on the left is a DFS that is connected to B2, just to show that there is a communication in between B also, right? So in the B1, I already have a user called Alice that I created in the previous stuff. And what I'm trying to do is that I'm trying to actually create B2 and give the boot node of the address of B1 as the boot node, so that it goes and connects with the B1, and it just connects and forms a network. So you can see this is connected. Wait a minute. Yes, this is successfully connected to this peer, and this also says the same thing. And I start the second B. Second B is empty, so I create a user called Bob. Bob creates a pod, and there is nothing inside the pod. Okay. So what I do here is that now I try to upload a new file called curls commands, which is just a small file. Upload the file. Yeah, once I upload the file, I get a reference. Now, what I want to do is that I want to share the file to user Bob. Now, when you share a file, you get something called as a share reference, right? So which includes a lot of other things like the encryption information of the file, not the file, entire file, or the metadata of the file, and who sent this file at what time, and blah, 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 all this information. So this reference is actually sent to Bob through some other means, email, telegram, whatever. There is no problem that somebody will actually take it and all these things. Now, what you do is in user Bob, you actually take this and run command called receive info and give the same hash. This will say that what is that file that is being shared with me? Do I really need to get the file, or I don't like the file? So once you decide that, yeah, I need the file, you say receive this file and at this directory location, right? And the file is there. Boom. It is showing in your ls. You can do stat like you used to do. You can also do cat to show the contents of the file. Now this file has been moved from user A to user B, which are connected to two different Bs. That means we use the same fundamental B mechanisms to transfer information from one B to another B. It's basically SOC chunks and the same content address chunks, which is exactly the same as in B. So what you have to take back is that DFS is a stateless layer which provides all this abstraction. When I say stateless, all the state that you do, you upload a file, you create metadata, you do a sharing, everything is stored only in Swarm. That means it has a very distinct advantage that if you have the key, if you have your key, you can go to any other device in the world and can just log in using that key and your data is available to you there. Boom, right? This is very, very, very important because we don't have a state. We don't store state here. We store all the state in Swarm, which is what Swarm is very good at. And we make use of that 100%. You would have seen, directories. Now, if I add something in the directory, I can remove something from the directory. So the entity which I call directory is actually a mutable entity. So in Swarm, everything is immutable. So the SOC chunk in Swarm exposes this immutability stuff to outside world. But what I have done here is that we have built something called feeds, which was there in the older Swarm, along with this SOC, which is the new technology, and provided a mutable structure on top of this, which is like simulates the real world scenario, right? And I want to go back to my presentation just to show you, there are a lot of things that we need help. Like if you go to FairOS DFS, there are a lot of issues there. We want to create pod that can be shared, which is like an NTFS file system across an organization. We want to create a lot of other things like, let me go to these FairOS DFS issues. So yeah, so we want to actually charge BZZ tokens for uploading and downloading a file. So it's not free, right? It's not free. Like Michelle said, if it is free, then you are the product. So it's not free to upload a file and download a file. So when the storage incentives in Swarm comes up, we are very close with Swarm team, or I am also working in Swarm team. So we know when things are moving, when things are coming out, and we will build this storage incentives and all these kinds of stuffs right into this layer, so that when you upload something, it will say that, okay, if you store this file for this much time, this much BZZ token will be gone, right? And you should prepaid, you should maybe top up your prepaid wallet for BZZ so that it stays there. If it is not there, then it's your own risk, because things can be garbage collected, right? So things like that, right? There are a lot of other things like, file seek support, creating soft links so that I don't hold two same files, or two different people hold two same files and waste the space, and all these kinds of things.
Sahur, I have to nudge you a little bit to move on to maybe show the next thing, which I
Which
think
is
is, yes,
fair.
it's not that I want to take credit here, but this is the thing we
No,
have
no,
been
no,
working
no,
on
I just want
together.
thank you very much for reminding. I'm a guy who's like really, really not uh, time bound, and I keep on speaking a lot. So thank you very much for reminding. So as I said, right, this is like a platform which enables developers to make a lot of nice apps. And our nice Michelle, she did a beautiful app called Fair Drive. It is a it I mean, all these things what we have done are baby steps. Of course, there are a lot of things to do. So what this Fair Drive does is that it creates a drive for you. It gives a UI punch to use the system that I was explaining. So you can log in as a user. You can create a user. You can log in as a user. I hope I have given the correct password. Yes. So this is my Fair Drive. I have some documents, movies, music, picture, my folder. I think in the last demo, I uploaded the Fair OS presentation itself. So you could download the file, you could share the file with another person. All these kinds of things are built into this. This is exactly what we want to show as the in a way where this uses Fair OS's APIs directly, right? And it becomes so simple to build applications like this on top of this, to store information, to retrieve information, to store metadata, to do all kinds of things on the data that you are usually used to, right? Even the login and all these things are very Web2 compatible and all these things. So yeah, I mean, we are slowly looking at how to introduce other Web3 concepts into that, like.
Yeah. So yes, thank you so much, Sahur. I just want to remind everybody that this is just like a fast prototype, and that it would be really cool if people join us up in building this. Sahur, thank you so much for your presentation, and we'll be seeing you later, or in a couple of minutes, I think, in the AMA.
Thank
So
you very
please.
much. Thank you very much, Michelle. It's pleasure always talking to you.
Thank you, Sahur, and I'll see you later.